during all the motion basically. And depending on the magnitude of forces, he reacts or waits until he again thinks, okay, there is no object anymore. Then he goes there, finds the object, grasps it. And the idea is also to interact dynamically during the entire motion. So you can just touch the robot very slightly, and then he gives me feedback, what is the executions or tasks which we could do now. Right? So this is still ongoing work, of course. Huh? Did you have it again? Okay, and now he just tells me, if you push from the side, I just open the gripper. Now if I try to trick him, he knows, okay, there is nothing. And if I again push it in, he closes and knows it's there. And then he again tells me, okay, what do you want to do now? I want you to continue. He continues. Right? So it's a very intuitive kind of interaction. And now again here I can always interact with the robot and apply physical forces on the robot. This is a very unique feature about the systems we built here. And now again I can always interact with the robot to kind of stop him or help him in the during task execution. And the idea is also that I can actually take the robot or disturb the robot during the motion. So now let's just wait until it finds another object. And then I will show you how he actually safely interacts with humans. So for example, now he goes therefore a closer look. When he finds an object, now I just push my hand here and he detects, oh, this force is too high, I have to retract again. This is not working. Right? So this is a very basic feature, a very important feature to reduce physical forces between humans and robots to make them safe. Right? There is no help if I have all kinds of computer vision and these kind of things which always fail in the worst case. So what we want to have is really robots which can, based on the physical environment, the physical forces, be in a safe manner. So now the next thing I want to show you is kind of, there are all kinds of modes. So now if the robot is coming and he wants to again find the object, I can always, if I'm not satisfied with the program that I did there, I can take him out of the motion and tell him, no, you did something wrong, and I just suspend him to a kind of virtual plane here. There he's very compliant, so I can actually move a 14 kilogram robot just by very small forces. But he's compensating for his own weight. And here he's kind of confined, but if I tell him, now, continue please, then he again continues in the task, or now he waits for me again to confirm, please continue with the task. So I could reprogram the robot if I see something is wrong. So what we want to do is to use, or to get rid of. We want to get rid of all interaction devices which distract me from the robot. So when I want to do human-robot interaction, I want to interact with the robot and not with the teach panel, right? And we want to facilitate the intrinsic capabilities of the robot to a very large extent. This is kind of the idea of everything we do. And since humans are kind of the worst case for interaction, because they do whatever they want, they produce forces whenever they want, this is a very important proof of concept for our for basically all our control algorithms for space, right? Because there everything is much better known than on Earth. So that's why basically we also go into these terrestrial applications, because they are usually by means of dynamics and by means of unknown conditions very much more complex. Okay, maybe one thing? No. I leave it, and if there are questions, please feel free to ask.